numbers that might ultimately be of particular opportunity for your code to break. Questions of any sort? Yeah?
How exactly do you implement the return one?
How do you implement the return one? Implement it in what sense?
Like, how do you use it to like jump back to get int?
Good question. So how do you use return one to get another int from the user? In short, you don't. So this was a deliberate design decision in this program that I'm not going to use a while loop or a for loop or a do while loop to ask the user again and again. If they don't give me what I ask for, which is a non-zero number of bottles, then I'm just going to quit immediately because it's not a fun song to sing. But we could have done this with a do while loop like in the P sets. Yeah? So how do you use this number return one? So short answer, we're not going to yet. But starting next week, we're going to introduce something called a debugger, which is a separate tool from the compiler that actually lets you figure out what's going on inside of the computer and even lets you step through your code line by line by line. And for that tool and others, the return code is going to be useful. For now, it's the sort of thing, just take it on faith because it will soon become useful. So we now have beer 2. So we want to do something a little better here and introduce kind of a big topic that, frankly, you might see in a textbook, but no one ever really says it in person, which is that of hierarchical decomposition. So what does this actually mean, and who cares? So let me scroll down now to actually let me go with, let's go with beer4.c. Yeah, this is the one I want. OK, so in programming, you'll often find yourself doing something a little repeatedly. Like if you yourself have been writing programs where you're kind of stealing code you wrote a few minutes ago on some other line and pasting it, that's probably going to be an opportunity for hierarchical decomposition, which just means write your own function. So thus far, we've been using main, which we have to write a program from the get-go. You've been using printf, which someone else wrote. You've been using getInt, which someone else wrote. So you haven't really, most likely, written your own function. And yet this is actually relatively easy. And it's not even new syntax. We just kind of mimic the same syntax we've seen with getInt and printf and main. So let's take a look at this version here. So if I zoom in here, notice at the very top of this file, I have, again, the same code at the top. How many bottles of beer will there be? I get an int from the user. I quit immediately by returning 1 if they don't cooperate. And then I have this two-liner, which is kind of interesting for a couple of reasons. So one, I have a while loop now. Why? It's just a little different from a for loop. I decided to do this aesthetically. But what's interesting, too, is I've got n minus minus. We'll come back to that. But more interestingly, all of a sudden, there's a chorus function that apparently I could have been using all this time to print out the chorus, that 4-line stanza, of this song. It's as though I've now outsourced to a little black box called chorus that itself is a function that someone else wrote, and that function's purpose in life is to sing this song for me. So I don't have to write these lines myself. Now, in reality, someone did have to write those lines, and in reality, it was me. And if you scroll down to the bottom of this file now, notice the following. So this is familiar syntax, even though we've not used this too many times thus far. The thing with the stars, that's just a comment. /*, then some stuff, then */. That's a multi-line comment. And that's just my note to myself, sings about specified number of bottles. Then below that, I have something that's similar syntactically, but still a bit new conceptually. I've got void, and then the word chorus, and then int b. And then inside of this, I've got a couple of new features. I have this new syntax, which we'll come to in a moment. So let's ignore anything we don't quite understand yet and focus only on this. Well, this is kind of interesting. Sing verses. So what am I doing that's different here? So I still have my %d, but what format code is now obviously new? So %s. So I'm actually fixing a couple of problems now and refining this code with a more sophisticated implementation. %d is still going to be the value of the number of bottles of beer. %s is going to be which of two words, even if you just take a guess. It's going to be bottle or bottles. So I'm fixing that grammar problem that I admitted to on Monday. So we'll come back to how that's working in just a moment. But B, what happened to I? Well, this is the fundamentally interesting aspect of actually writing your own functions. Notice that at the top of this function, I've specified what kind of input this function called chorus takes. And it's pretty obvious that it takes an int. And just because I'm going to be talking about bottles, I decided that B is a reasonable name for the variable to give to the input to this function. Now, notice how I'm using chorus. If I go up here, and actually let me simplify this just for a moment. I'm going to change this code just for the moment to I minus minus, and then this close brace here. So notice on every iteration of this while loop, if I start by typing in 99 for n, what value apparently gets passed inside of parentheses to this function called chorus? This is 99, right? Whatever value's in n is what gets handed to chorus as an input. All right, so now let me scroll down to the bottom here. Well, just because chorus takes an int doesn't mean it has to take an int whose name is identical to what the original value was. I can name it anything I want, and I decided stylistically B makes sense because I'm talking about bottles. So what's going to happen then is when I call the chorus function up in main by just writing chorus, open parenthesis, n, close parenthesis, semicolon, what's going to happen is that chorus is going to get executed and be handed as input that number, 99, and it's going to get its own copy of 99, its own 32 bits, its own 4 bytes somewhere in RAM, and they're just going to be called B in the context of this function. Now, what am I doing with B? Well, let's scroll down to the printfs. Well, I'm apparently plugging in for %d, the value B. I'm plugging in for the value %d, the value B again. And then in the very last line, I'm plugging in for %d, B minus 1. So functionally, this is equivalent. All I've done is kind of outsourced now the singing of this song to someone other than main, and that someone is a new function called chorus. So now what about S2 and S1? Well, let me rewrite something quickly as this. If B equals 1, then I'm going to do this. String 1, S2. I'm going to say S1 gets bottle, else S1 gets bottles. And then I'm going to do a quick copy paste here. And actually, let me clean this up. I'll do this on the fly. S2. And I'm going to do S1 up here. And I'm going to say if bottle equals 2, then I'm going to say S2 gets bottle, bottles. All right, so what is going on here? So first, let's ignore the goal and focus only on the syntax. Well, what does it mean if I say string S1 in a program? Just translate that to English. OK, not quite initialize, but declare a variable of type string and call it S1. This is identical conceptually to doing something like int n, semicolon. That means declare an integer, call it n, and that's it, because there's no equal sign. Don't do anything else with it yet. Now, a string, recall, is just a word, a phrase, a sentence, a paragraph. It's some number of characters. So string S1 means, OK, prepare to get me a string. And that string is going to be called S1. So what am I doing here? Well, if the number of bottles passed in equals 1, I want this string to represent bottle in the singular. Else, if B is anything else, 2, 3, 4, 5, whatever, then I want it to be bottles. So it seems like now I'm using just a branching condition to fix some grammar. And then I actually have S2 down here, but we'll see why in just a moment. So let me scroll down here and see what I'm doing. So printf %d. So if I type in 99, that goes there. If I type in 99, what's going to go here for %s if what I'm putting in there is S1? Bottles, right? So again, I'm just creating a variable on the fly here, string S1. And if B equals 1, make S1 be bottle in the singular. Else, make S1 be bottles in the plural. And so that's what gets plugged in there. Now, why S2? I'm going to wave my hand at this detail just for now. But it's simply because in the very last line of this song again, I might need to change the pluralization. Right? It might go from bottle to bottles, because it might be 1 bottle to 0 bottles, or it might be 2 bottles to 1 bottle. And so you need to have 2 different words. One might be singular, one might be plural, or vice versa, or they might both be plural. So that's simply why I have S1 and S2. Now, in terms of conditions, like we've done this before, right? If this, else that. And just so you've seen new syntax, it turns out that syntactically, These two lines at the very top are what we would call a very elegant one-line implementation of that same idea. By no means strictly required. Doing it the way I did here with the indentation and whatnot is perfectly fine. But let's just see what this is. This is the only funky line of code we're going to see for a while that has multiple pieces of punctuation in the middle of it. So what's going on here? Well, let's do the first part on the left. String S1 means give me a string, call it S1. That's it. The equal sign means put some value in there. So the last question to ask ourselves is, what value do you want to put there? Well, it turns out that this expression right here is identical to this. It's just a slightly more succinct, dare say, a prettier way of expressing that same idea. What this means is that if b equals 1, the word after the question mark is going to get plopped into S1. Else, so this colon represents else now, else bottles in the plural is going to get plopped into S1. So in other words, it collapses all 5 of these lines into one line that once you know the syntax, it's just a little easier to swallow, just a little easier to read. But let me point out one thing. I intentionally did this, string S1. Why, if you think back to Monday, did I not do this? It's only if I declare a variable, in this case a string, inside of a condition, that's pretty much equivalent, recall, to writing this, even though the curly braces are not necessary if it's just one line. But conceptually, it's equivalent to this. And what was the rule of thumb we discussed on Monday when it comes to variables? Scope. They're only in scope. They only exist inside of the confines of the most recent curly braces, even if those curly braces have been omitted just because it's one line of code for convenience. Those variables only exist inside of those curly braces, which means I'm kind of out of luck if I want to use S1 down here. And so the solution is simply make sure that the strings are declared outside of those conditions. So this, again, is a question of scope. So in short, we've solved a few problems here all at once. So on the one hand, with chorus, we declared our own function. It takes input. And now I don't have to clutter up my main function. If I have this well-defined task, sing the chorus of a song, that's a candidate for hierarchical decomposition. It just means factor it out. Create a little black box, give it a user-friendly name like chorus, define it as taking some input like an integer, call it whatever you want, b, and then it does something. And the only last question to ask about the syntax here is, what does it mean if chorus is prefixed with this word void? So not input. So it does take input because the input is always defined between the parentheses. So what's the opposite of input? So output. So this means chorus does not have any output. Now, this feels like a bit of a lie, because clearly this song is going to have some kind of output. What's it going to do? Well, it's going to print a whole bunch of stuff to the screen based on these printf lines. But this is a different type of output. Recall that you can print something to the screen, but you can also hand the user back a value. For instance, what's a function you've been using for a week or more now that returns some value? So getInt, right? GetInt, getString, getDouble. In those cases, the function getInt, it doesn't just print it out on the screen and leave it for you, the human, to figure out what it was. It returns it, so to speak, so that you can put it to the right of an equal sign so that you can assign its return value to some variable. Well, same idea here. Chorus, though, his only purpose in life is to have these aesthetic side effects of printing something to the screen. It doesn't actually hand the user back any value, any sentence, any string whatsoever. It just prints, and so its return type is void. And we'll see this again and again in more clarity. Yeah?